As we already saw in the presentation slides, we are first finding out the shortest route to be followed by the truck from warehouse to the distribution centers. Once the route is found, we are all sorted. But actually we are not. Real life problems are not that simple. In real life setting, we have certain set of operations constraint as well. So the problem we are trying to solve is actually a mixture of routing and assignment problem. Routing problem as we are already seen, an assignment problem as we are going to assign an optimal number of trucks in a dedicated route. So now our objective changes a bit and it becomes to minimize the total route cost by minimizing time with a certain number of constraints present in the system. We have made certain assumptions regarding the model we have built. The first being a designated route is assigned to each of the truck and it starts and ends its operation at its own depot, such that all requirements are satisfied. Later, we also find out the total optimal vehicles to be used in a particular route to maximize the objective. Now let's run the model and see how the simulation looks like. So the warehouse is in red color, sorry it's hidden by the truck, sorry for the wrong color combination chosen. And the distribution centers are shown in yellow. The red dots over the distribution center show that it is in a waiting state. The trucks are following the dedicated routes as uh, assigned to them. Now, sorry. So now we are seeing how they're moving. Now internally we can see where exactly how many trucks are doing what all things. We can actually see how they're going about our constraints that we have modeled. So now as we can see here, so so now the trucks are in the warehouse and they're getting goods back to leave for the distribution centers. So once they leave for the distribution centers, there could be natural conditions like traffic or or any other such factor like roadblock due to high volume of lorry, congested route, or any of such that. So once it reaches the distribution center, it does unpacking, and once unpacking is over, then it is released back to its unit, that is the warehouse. So this shows the total number of truck allocation. So the model gets totally run, and here what you can see is the time. So this is the time, the total time that is taken till the total number of trucks are utilized. So now you can run n number of models and we can find out the optimal time needed, the best time needed by a model when a certain route is selected. Once we do that, we are ready to go. Now coming to the second set of problem, which is actually to find the certain number of trucks that has to be used in a particular route. So for that we'll run our optimal model and see how it goes. We are running our optimal model. So now the model shows nothing. Now you can see that here you can see the number of iterations. Here you can see how much percentage your experiment has completed, and here you can see the output. So now you saw that in iteration 2 it was coming infeasible. Okay, now the model has run 10 iterations and it is showing finished. Now it shows that in 6th iteration it achieved the best result. While running the 10 iterations, it is showing that it has achieved this much of time. It is taking this much of time. Like when 9 trucks are in the system, and in 10th iteration, it has achieved like this much of time. So when we are using 2 trucks, and which is in the 6th iteration, it is taking 0.43 hours of time. So like 4 hours something as time. So now it is up to the business to choose this combination or this combination. Thank you.